Hello, my dear friends, and hope the previous videos recorded by me have been useful for you. And today I'm going to record last minute preparation for instruments. Remembering these formulas, last revision will help you to solve the numericals which you have been doing so far. So keep them for a fast track revision, last 1 or 2 days, and ensure that you know all these formulas before you enter the examination hall. These are a summary of what we have learned so far. So I'm not going to teach you today how to use these formulas. I'm going to tell you what are these formulas. By now, you must have learned how to use them. If not, go back to my previous lessons. Now, here is a summary for you. For altimeter, air speed indicator, and machmeter, these three pressure instruments. What all I must remember when I go into the examination, that an altimeter gives you the indicated altitude, or which is called altimeter reading, which is nothing else but the pressure at the level at which you are flying minus the pressure you have set in this Boltzmann window, this small window where you set your datum pressure by the pressure setting knob. So this reading, the difference of this reading or this ambient pressure will always be less. Or the other way around, what is your datum pressure minus what is the pressure at that altitude? The difference, in other words, whichever way you take it. This reading, don't take it as plus or minus, just see the difference. Difference in ambient pressure, datum pressure, and multiply if both these are in HPA. Multiply with the 30. If both these are in inches, multiply with 1016, and you will get your altimeter reading in feet. This is your altimeter reading displayed here. Okay, 1,000 feet needle, 10,000 feet needle, 100 feet needle. Now, how to calculate QNH? QFE plus aerodrome elevation divided by 30 HPA. When you set QNH, your reading of the altimeter will be called altitude. When you set QFE on your data point, it will be known as height. We don't use the QFF in altimeter, but QFF is the actual mean sea level pressure, which is calculated with the pressure at an aerodrome called QFE, or pressure at the field elevation, plus aerodrome elevation divided by the actual lapse rate. If it's in HPA, add in HPA. Density of altitude affects the performance of the aeroplane and is your pressure altitude corrected for the density error, and that is 118.6 into ISA deviation at that level. If the deviation is plus, that means warm air, then your density altitude will be more. It means the actual density at this altitude which you are flying is less. And this is your density altitude. Your aircraft performance is as per your density altitude and not your altimeter reading, which is your pressure altitude. Altimeter reading can be changed by the pilot in the air also. If you increase the subscale reading, that is your datum pressure reading here, your window reading, your main scale reading will also increase. And the main scale reading is the reading on your altimeter. And this is called subscale reading. To find out the true altitude, to ensure that you are crossing the hills below with a safe margin, if you're flying rather too close to the hills, then find out your indicated altitude on QNH. Same way. If the flight level is given to you, first convert it into indicated altitude on QNH, set the QNH. So when you change your subscale reading, main scale reading will also change. If subscale reading reduces, main scale reading will also reduce. If it increases, both will increase. So this will give you the true altitude. To this altitude on QNH, add or subtract 4% of indicated altitude for every 10-degree ISA deviation. If the deviation is 15 degrees, apply a correction of 6%. 5 degrees, a correction of 2%. When do I add or subtract? If your deviation is plus, add this correction. If the deviation is minus, subtract this correction value and do the indicated altitude, and you will get your true altitude. And remember, ISA deviation is ambient temperature, still air temperature, outside air temperature at the level at which you're flying, minus what should have been under ISA conditions in the bracket. If it is minus, minus will become plus. To calculate TISA plus 15, that is the mean sea level temperature, minus a fall of approximately 2 degrees Celsius per 1,000 feet. In other words, at 20,000 feet, the temperature fall will be 40 degrees from plus 15 minus 40 will be minus 25, and that is known as TISA. Apply it here. You will need it here also. Then to correct for the barometric error, see your datum pressure error. But barometric error is due to the reason that your altimeter datum is set, let's say to 1013.25 in your flying flight levels, but the actual pressure at the place is different. So therefore, your altimeter reading will not be correct. To correct, and this is known as the pressure error or barometric error. See what is your datum pressure or your altimeter setting on the Colesman window. And this is the pressure which will be in your capsule in your altimeter. If the actual pressure is low, then high, low, due to barometric error, altimeter will read high. And read high means it will overread, which it means indicated altitude will be more than the true altitude by an amount. The difference of these two multiplied by 30 if in millibars, or multiplied by 1016 if both are in inches. Apply this correction to get the true altitude, and then you compare it with the ground below, hill elevation. Hill elevation is nothing else but true altitude of the top of the hill. Similarly, if altimeter setting is low, actual pressure is high. Due to barometric error, altimeter reads low. Low means underread, it reads less. Indicated will be less than the true altitude. Then your true altitude will be more. Okay. As far as ASI is concerned, remember these formulas and they are to be done on your nav calculator. ASI gives you the indicated airspeed. Apply a position and instrument error correction from the card which is fitted in your cockpit. And you will get rectified or the calibrated airspeed. Now go to your nav calculator. Your nav calculator will correct this rectified or calibrated airspeed for density and compressibility error. Density error is due to the fact that the instrument is calibrated for standard mean sea level density, and the place where you're flying, the density may not be same. And if you're flying at higher altitudes, it will be less. We know it. And compressibility error occurs if a true airspeed of more than 300 knots, then the air inside the capsule starts getting compressed, temperatures rise, pressure also rises, and your airspeed indicator reading also rises, capsule expands. So your nav calculator will correct for both these. And although RAS, in theory, if you correct only for compressibility error, you get equivalent airspeed. Equivalent airspeed then corrected for density gives you true airspeed. But your nav calculator will correct for both. Then again, go to the nav calculator with this true airspeed and the track. The Americans call it course true, CRST. Apply the wind velocity, which you will obtain from your met section, and you will get the ground speed. With this ground speed, you will calculate your timings for the each leg of the flight. So you'll calculate separate climb ground speed, separate for cruising and separate for descending. Fine. Now, as far as the Mach number is concerned, it's a ratio of true airspeed to the local speed of sound. Speed of sound is not constant. And the place where we are flying, what is the speed of sound is called local speed of sound. And it is 39 approximate value. We use it 39 to make our life easy. Square root of ambient temperature in Kelvin. Don't use the ISA temperature. If you use ISA temperature, it will give you speed of sound under ISA conditions. There are 4 variables when you're climbing or descending, which can change in your machmeter. One is the Mach number itself, if V changes or C changes, and the indicated airspeed. So depending upon what you are maintaining constant, other things could change. The speed of sound is not in the hands of the pilot. Leave it to God, who will decide the temperature at that level. You only can calculate it with the speed of sound, that this will be my speed of sound. Then if you know the Mach number, you can calculate true airspeed. If you know the true airspeed, you can calculate Mach number. Theoretically, the indicated airspeed is directly proportional to the density at that level when you're flying at a constant true airspeed. Now, true airspeed by itself will of course depend upon the indicated airspeed, but if the indicated airspeed is constant, then it depends upon density. It will change with the density, and density will change with the pressure. Even at a constant IS, if you fly into an area of higher pressure, your density will increase and true airspeed will decrease. Similarly, density is inversely proportional to the temperature and also inversely proportional to the humidity. These are some of the formulas or the applications. Last day revision will help you to do your numericals. Although you should not wait for the last day. By now, you should have remembered all of them. And if need be, if it is likely to cause a confusion, let me write this as altimeter reading or indicated altitude is datum pressure that is in your window minus ambient pressure into 30, or in simple words, the pressure which you have set minus the pressure at which you are applying into 30. The altimeter is calculated for a standard lapse rate of 1 millibar every 30 feet, which when converted into inches becomes 1 inch for every 1016 feet. 29.92 inches. Mean sea level, standard mean sea level pressure is equal to 1013.25 HPA. So you can do the unitary method. If this is inches, 1 inch will be equal to this divided by this, and so many inches will be 45 inches will be equal to this unitary method, or you can convert the pressure on inches into HPA and vice versa on your nav calculator also. Now here we are. I'll stop it. Leave this lesson short and sweet for you, and don't forget to use it and for your last minute preparation of your exams. And good luck, all the best. Wishing you all the success, not only in this exam, but in your entire flying career. Do keep sharing my videos with your friends also in the flying clubs, or if you are already a pilot, with your junior colleagues, with your younger brothers, sisters who are preparing for the examination. And do subscribe to my videos. It will encourage me to post some more. And in case I will be going systematically and finally posting all the videos. In case there is a lot of demand for a particular video for numericals, then I may skip the queue and post that in one of the future videos. Good luck, all the best. And if you like it, do press the like button and subscribe button. Thanks a lot. See you next time. This is SK Booty here, signing off for the day.